Hi everyone. Now we will do two examples about adding repeating decimals. So we will convert them directly and add them. Remember that first if we write all the numbers as they are 0, 2, then minus till the repeating part just 0. Actually no need to write, but I want to do it in general form. So for denominator we check after the comma how many numbers are there. There is only one number and that is repeating. So for that we put a 9. So we write all the numbers 0, 5 minus till the repeating part 0 over. For the denominator part we look for after the comma there's only one number which is repeating. We put number 9 for that. So it is actually 2 over 9 plus 5 over 9, which is 7 over 9. So then in this place we are going to use the same rule. First you write all the numbers as they are, then minus till the repeating part 1 over. After comma we have one number which is repeating, we put 9 for it, then minus we write all the numbers 0, 1, 3, then minus until the repeating part which is 1 is not included over there. This doesn't extend over there. I hope that you are able to see it in the video. This one till there and this one covers only 2. So there are firstly till the repeating part there is only number 1 over. For denominator part we look for after comma there are two numbers, so one repeating. For repeating number we put 9, after comma the two numbers, and the other one is not repeating, we put 0 for it. So 12 minus 1 will be 11, but we need 90 over there to make that calculation subtraction, so we multiply both by 10. So 12 minus 1 11 times 10 will be 110 over 9 times 10 will be 90, minus 13 minus 1 will be 12 over 90. So 110 minus 12 makes 98 over 90. Since we can divide both of them by 2, we can simplify. We keep simplifying until we can. This makes 45. That makes 45 plus 4, 49. So with 7, no, not possible. So that will be the final answer. So then here we have complex fractions, adding, subtracting. So we have first part, then minus second part, then plus. Here we have mixed fractions in here. So let's not copy those things again and again. Let's make this part in one place, which is that, let me do it in here. 1 plus 1 over 2. At the same time I'm going to do the calculation, division into multiplication. Then you flip the second fraction becomes 3 over 1. So you will have 3 over 2. Let's make it 1 over 1 and enlarge it by 2. 2 times 1, 2, 2 times 1, 2, plus 3 over 2 equals 5 over 2. So then we did finish the first part. Now the second part. So there is the point in here which actually means times. So 1 plus 1 over 2. Actually you can make directly this in here, 2 over 2. So, or you can make it like a mixed fraction, like a, yeah, 1 and 1 over 2. 1 times 2, 2 plus 1, 3. Anyway, let's copy it in here one more time. We will make it 1 over 1 and plus 1 over 2. We will enlarge this by 2 inside the parentheses, then times 0, 3. We will convert it into the rational form. All the numbers 0 and 3 minus till the repeating 0, which is, so it will be 3 up there. Denominator, after the comma we have one number and repeating, which is 9. Then plus one more, so we can write instead of 1, 1 over 1. In future we mean it, so 2 times 1, 2, 2 times 1, 2. It will be 2 over 2, so 2 plus 1 is going to be equal to 3 over 2 times 3 over 9. We can also simplify this by 3. By 3, 1, by 3, 3. It's going to be 1 over 3. Then plus. So at the same time I'm or let's not do it. So 3 and 3 simplifies each other, and we will have 1 over 2 plus this part. Let's make it into 2 over 2, which is we are going to have the result 3 over 2. So then if we write all these things back in the original form, 1 minus the 1 from here minus 3 over 4, then plus the result for up there is in here 5 over 2, and this result for this place 3 over 2. So then which equals 1 minus 3 over 4 plus 5 over 2, we keep same, and this division into times 3 over 2, flip it, 2 over 3 it will become. 2 and 2 simplifies each other in there, so let's make equal from here. 1 over 1, let's write instead of 1, minus 3 over 4, then plus 5 over 3 we have. So we need to equalize those numbers, so it's going to be times 12 and times 3 we need in this place, and times 4. We should make denominators the same, so it will be 12 over 12 the first, minus 3 times 3, 9 over 12, plus 4 times 5, 20 over 4 times 3, 12. 12 minus 9 makes 3 plus 20, 23 over 12 is the final result. So then one more mixed fraction form. Let's do it like the other one. I'm gonna do this one in the other place. So 1 plus 1 over, I need to calculate this part firstly. 1 over 1 I write, and I do it times 2. So when I copy it down in here, 1 plus 1 over 2 over 2 plus 1 over 2. So 2 plus 1, 3 over 2 I will have in here. So 1 plus 1 stays the same. 1 times 3 over 2, you will flip it and you will make it 2 over 3. So we make this one 1 over 1 and times 3, which is going to be 3 over 3 plus 2 over 3 makes 5 over 3. The first part. Then the second part, I'm gonna do it in red color. This is the second part. So we will write that over 1 and times 3 we are going to need. So 1 plus 1 over 1 plus 1 over 3 over 3, which is 3 times 1, 3 times 1, plus 1 over 3, which is going to be 1 plus 3 plus 1, 4. 4 over 3 we will have in here. So this number 1 stays the same, times 4 over 3, you flip it into 3 over 4. So then you write 1 over 1 in there, and times 4 we need to make the denominator same. So 1 will be same with 4 over 4 plus 3 over 4, which is equal to 7 over 4. So now let's put those numbers back in here. 1 plus the red part 7 over 4, and the purple part is 5 over 3, which is equal to 1 plus 7 over 4 stays the same, times 5 over 3 turns into 3 over 5. 4 times 5 will be 20, so instead of 1 I'm gonna write 20 over 20, or like the all other places 1 over 1 then times 20 we should write over there. Then 7 times 3 will be 21, and 4 times 5 will be 20. I didn't simplify anything because I can simplify 4 with 7, 4 with 3, and I can simplify 5 with 3, 5 with 7. So 20 plus 21 will be equal to 41 over 20, which is the final result. So this question is something else. Let's stop this video in here.